have our losses. So we've talked about the losses through thermal bridges, walls, roof, slab, windows, air leakage, and ventilation. That's all our losses we have to add up. And then we have to compare them to our gains, our solar gains through the glazing, internal heat gains. And now we need to bring that into a balance. Okay, so this is our losses, our gains. We have to bring that into a balance. And that part that's missing to bring it into balance is our heating demand. Okay, so that's probably a good way to see it. So this is just what it means. So you can look at that again, what it refers to, our QT of our thermal bridges, U value and volume, and then our gains. And this is our heating demand. And this is the formula if you write it in that we've just seen. And now what we need to do is we want to reduce this heating demand, okay, as much as possible. And we can do that in two ways. The one way is we could increase our gains. So we could say, okay, if we have more gains, we have a smaller heating demand, but we have to be careful that we're not overheating in summer. So that's one thing we have to be careful of. We're not getting too many gains and we're making an overheating problem. The other solution would be we could reduce our losses. Okay, so we could bring those losses down, and that also means that our heating demand will go slower. And this is probably the main focus of what a passive house designer does, to reduce the losses as much as possible so that we get a balance where that heating demand is small.